Today we're going to be covering Lesson 16-2, Graphing Inequalities in Two Variables. The first thing we're going to do is we are going to unpack our learning targets. We're going to start by saying the graph on a coordinate plane. We're going to on a coordinate plane the solutions of a linear inequality in two variables. So what are we going to be doing? Graphing on a coordinate plane. Interpret the graph of the solutions of a linear inequality in two variables. We are going to be interpreting the graph of the solutions. Today's lesson will be split into three separate sections. We will have example A and B together, along with question number 1. Then we're going to do questions 2 and 3, and then we're going to round this out with question 4. Let's take a look at some things that you might have seen on the previous slide. The solutions of a linear inequality in two variables can be represented in the coordinate plane. A line that separates the coordinate plane into two regions is called a boundary line, and the two regions are called half-planes. The origin 0, 0 is usually an easy point to test if it's not on the boundary line. A closed half-plane includes the points on the boundary line. An open half-plane does not include the points on the boundary line. It says in example A, the solution set includes the points on the boundary line. The solution set in a closed half-plane, an inequality containing less than or greater than, the solution set does not include the points on the boundary line, so the boundary line is dashed, and the solution set is an open half-plane. You would have seen one more tip on the previous slide, and that tip would have said, when multiplying or dividing each side of an inequality by a negative number, you must reverse the inequality symbols. All right, let's take a look through example A. Example A states, graph the linear inequality y less than or equal to 2x plus 3. Step 1. Graph the corresponding linear inequation, y equals 2x plus 3. The line you graphed is called the boundary line. So notice that they started at the y-intercept of 3, and then they increased by 2, 1 over 1. Increased by 2, 1 over 1. So started with the y-intercept. My y-intercept was 3, slope of 2. It says use a test point in one of the half-planes to see if the solution of the inequality is true. Using 0, 0, because 0, 0 is not on my line, I can see that 0 less than or equal to 2 times 0 plus 3 is a true statement, because 2 times 0 is 0, plus 3 is 3, and 0 is less than 3. So that means that this is in my solution set. So we would shade, if the point you tested is a solution, shade the half-plane in which it lies. If it is not, shade the other part. 0, 0 is a solution, so shade the half-plane containing the point 0, 0. Again, they called this a closed half-plane because the line was solid. Let's take a look at the next page. The next page states, solve the inequality for y was step 1. So they subtracted x from both sides. We would have probably written it like this. Subtract x. We would have done 2y less than negative x plus 8. Then we would have divided everything by 2. y would have been greater than negative 1/2 x plus 4. So they graphed the boundary line as if it was an equal to, but notice because it did not contain the equal to, they made this line dashed. They used the points y-intercept of 4, that's right here, and then a slope of negative 1 over 2 to create that formation of that line. They tested the point 0, 0. Negative 1/2 times 0 is 0. 0 plus 4 is 4. 0 is not greater than 4. So notice my test point was over here. I did not shade that area. I shaded opposite of it. All right, let's take a look at these. Try these. We're going to work through these together. So you need a piece of graph paper, or else you're going to need to graph on the side in your My Notes section. But I know my pictures are going to be too big, so I grabbed a little piece of graph paper here. The first thing it asked us to do was solve this for y. So I got 3x minus 4y greater than or equal to negative 12. I'm going to subtract 3x. I've got negative 4y is greater than or equal to negative 3x minus 12. We're going to divide by negative 4 on both sides. But I want you to remember this tip that we just read. When multiplying or dividing each side of an inequality by a negative, you must reverse your inequality symbol. So when we do this, my symbol is going to change directions. It's now going to become less than 3/4 x, and this is going to say plus 3. So we have a y-intercept of 3. We have a slope of 3/4. So whenever I go to graph this, I'm going to create me an xy axis, a coordinate plane. I'm going to start at positive 3. So 1, 2, 3. I'm going to start here. Okay. It says go up 3, rise 3, run 4. 2, 3, 4. So we would have a point here. If I wanted to create a second point, I could go down 3 and back 4. I would still be on this same line. Now, because it contains an equal to, this is going to be solid. Okay, so I'm going to graph a solid line here. It always suggests sticking with the point 0, 0 if it's not on the line. Is 0, 0 on this line? No. So let's test it. Is 0 less than or equal to 3/4 times 0 plus 3? Well, 3/4 times 0 is 0. 0 plus 3 is 3. Is this a true statement? 0 less than or equal to 3. That is true. So since my test point was over here, we're going to shade on this side. So I would shade all this area down here. Everything below the line gets shaded. Move this sticker off to the side. Let's take a look at example B. All right. B states y less than or equal to 3x minus 2. This is already in slope-intercept form. My intercept is -2. My slope is 3. I'm going to create me an xy axis. I want to start at -2. We're going to go up 3. Now remember, we can always write this as a fraction of 3 over 1. So we're going to go up 3 over 1. Up 3 over 1. Now, look at your inequality symbol. No equal to. So this is going to be a dashed line. So make sure that whenever you do this, you pick up your pencil as you graph the line to leave gaps and spaces in between so we know that it is not equal to. Is 0, 0 on this line? No. I can use it as a test point then. So I want to know 0 less than 3 times 0 minus 2. 3 times 0 is 0. 0 minus 2 is -2. Is 0 less than -2? No, that is a false statement. So remember how my test point is over here? If we prove it to be false, that means we shade opposite side. So normally, if it was in it, I would shade this side of my picture. So since it's not in it, we're going to shade all of this section. All of this section would get shaded. Let's take a look at C. Okay. C states -2y greater than 6 plus x. Well, x is already on that side, so all we got to do is get rid of this -2 by dividing. Remember, if I divide by a negative, I've got to flip your sign. So we're going to say y is less than 6 divided by 2, -2 is -3, and 1 divided by 2 is -1/2 x. So my slope is -1/2. My y-intercept is -3. Let's create our xy axis. We're going to start at -3. It says go down 1 over 2. Down 1 over 2. Now, because this line does not contain that equal to, that inequality, we're going to have dashed here. So remember to pick up your pencil along the way. What is my favorite test point if it's not on the line? You're right, 0, 0. So let's try it out here. 0 less than -3 minus 1/2 times 0. 1/2 times 0 is 0, so -3 minus 0. Well, that's going to be -3. Is 0 less than -3? No. So instead of us shading the half, because remember this cuts it into two pieces, instead of shading the half with the 0, 0, we're going to shade the opposite side. So you should be shading all of this area down here. On to our last question from example A. Try these A, B. Okay. All right, let's look at D, and then we can move on to number 1, and wrap this section up. Let's take a look. Oops. Y less than or equal to negative 4x plus 5. Well, this is already in slope-intercept form, so let's just identify what we got. Our y-intercept is 5. Our slope is negative 4. Let's create our coordinate plane. We're going to start at negative 4. That's here. My slope tells me, backtrack that. I'm going to create this again. We're going to omit that one. I don't have white out here. Okay. So let me rewrite that. That was y less than or equal to negative 4x plus 5. We've got our y-intercept at positive 5. My slope at negative 4. Okay, create that xy axis again. Let's try this again. We're starting at y-intercept of positive 5. Now we're going to do our negative 4. Our slope is negative 4. So down to 4 over 1. Down 4 over 1. Okay. Is this a solid line or a dashed line by looking at our inequality? Because of that equal to line there, it is solid. So we're going to draft this line without picking up the pencil. It's just going to be straight connecting all the dots. No pencil pickup. My favorite test point, if it's not on the line, is 0, 0. So let's go ahead and plug that in. 0, 0 is not on that line. We're going to take in 0 less than or equal to negative 4 times 0 plus 5. Well, 0 is less than or equal to 0 plus 5. Is 0 less than or equal to 5? Yes, that's a true statement. So splits my graph into two pieces. We've got this piece and we have this piece, right? Well, my solution does work. That test point works. So we are shading all of this section over here that contains the point 0, 0. Okay, let's take a look at 1. When graphing a linear inequality, is it possible for a test point located on the boundary line to determine which half plane should be shaded, and explain? No. If you use a point on the line, then it will always hold true. Or false, depending on type of line. You must test a point not on the line. On to the next section.